Good morning. Today we are going to take question number 25 and 26 of exercise 6.5. Now question number 25 says that show that the semi-vertical angle of the cone of maximum volume and of given slant height is tan inverse root 2. Now it means that we have to maximize the volume of a cone of given slant height L. It means that L is a constant and we have to maximize the volume of a cone. Now let us take a simple figure of a cone of slant height L. Let the height be h and the radius be small r. Now we know that the volume of a cone is 1 by 3 pi r squared h. Now we have to maximize this volume. So now what is given to us is the slant height L. So we will try to convert the height in terms of r and L, so that ultimately the volume V is in the variable r only. So now clearly from this right angle triangle we have L is equal to under root of r square plus h square, or we have h square is equal to L square minus r square, and so we can write it as 1 by 3 pi r square. In place of h we will write under root of L square minus r square. Now we have to maximize this, but since it involves a square root term, we would like to work with a function which is free from square root. So squaring it, we get 1 upon 9 pi square r raised to power 4 L square minus r square. Now instead of maximizing V, we will maximize the function V square. Now clearly this V square function is in terms of only one variable, which is r, because L is a constant. Now here L is a constant because it is given to us. Okay, now differentiating the function V square with respect to r. So first of all, V square can be written as 1 upon 9 pi square L square r4 minus 1 upon 9 pi squared r raised to power 6. Therefore d by dr of V square is equal to, now this whole portion is a constant, we get 1 upon 9 pi square L square into 4r cube, minus this portion is a constant, we get pi square into 6r raised to power 5. Now let us take whatever common we are able to take. So d by dr of V square is equal to, we can take 1 upon 9 common, we can take pi squared common, we can take 2 common out of here. So 2 upon 9 pi square, and also we can take r cube common. So what we are left with is, now 1 upon 9 is, 2 upon 9 is gone, pi square is gone, so 2 is left here, L square is left here, minus, now here 1 upon 9, 3 upon 9, 2 upon 9 is gone, so 3 is left here, pi square is gone and r square is left here. Now for maxima or minima, we have to have d over dr of V square should be equal to 0. So it implies that r cube is equal to 0 or 2L square minus 3r square equal to 0. This gives us r equal to 0, which is not possible, or we have r square equal to 2 by 3 L square. So we have got one result as r square equal to 2 by 3 L square, which can be written as r is equal to 2 by 3 raised to the power of half into L. Okay, now corresponding to this we have to check the second order derivative. So differentiate d by dr of v square with respect to r, we get. So we get d2 over dr2 of v square is equal to. Now we can first write this as, you just open it up, you can write it as 2 or actually 4 by 9 pi square L square r cube minus 6 by 9 pi square 6 by 9 pi square r raised power of 5. Now differentiate this with respect to r. We get 4 by 9 gets carried down as it is, pi square L square 3 r square minus 6 by 9 pi square, and this is 5 r raised power 4. On substituting we get that this is less than 0 because this is negative, and which implies maxima. This you can check it out, this will give you a maxima. Now so it implies that corresponding to r equal to 2 by 3 square root of 2 by 3 into L, we get maximum volume. Now we have to find the value for, or the relation for the semi-vertical angle. Now the semi-vertical angle, let's call it alpha over here. Okay, now we observe from the result which is required to be found out, it is the angle is given to be in terms of tan inverse. So what we do is we find the value of tan of alpha. Now clearly from the figure we have tan alpha is equal to r over h. So we get r over h. Now here we have got r is equal to square root of 2 by 3 into L, and corresponding to this we will get, now h is equal to, here we have got the value of h is square root of L square minus r square. So using it here we get h is equal to square root of L square minus r square, which is square root of L square minus 2 by 3 L square, which is 1 by 3 L square whole under root, which is root of 1 by 3 into L. Now therefore we get tan alpha is equal to, in place of r we will write square root of 2 by 3 L upon, in place of h we will write square root of 1 by 3 L, and this gives us root 2, and this gives us the semi-vertical angle alpha as tan inverse root 2, hence proved. Okay. Now the same way we do the last question of this exercise, which is again a very important one, and the question says that, it's question number 26. The question says that, show that the semi-vertical angle of a right circular cone of a given surface area and maximum volume is sine inverse 1 upon 3. So again we take a cone having radius r, height h, the slant height as L, and the angle, the semi-vertical angle as alpha. Now we are given the surface area. Now when they say surface area, it means the total surface area. Total surface area. So total surface area will be the curved surface area plus the plus the area of the base. So we have pi r L plus pi r square is the surface area which is given to us, which is equal to constant as it is given to us. Okay, so from here we will find the value of L in terms of r and the constant s. So let's solve for L. It will be s minus pi r square over pi r, which gives you s upon pi r minus pi r square over pi r, which is r. And so we get the value of L as s upon pi r minus r. Now we have to maximize the volume. So to maximize the volume V of the cone, volume V equal to 1 upon 3 pi r squared h, which is equal to 1 upon 3 pi r squared, and in place of h we will write under root of L squared minus r squared. Now we have to write okay, now we have to maximize the volume. So we need to remove this square root sign from the volumes. It's easier for us to maximize a function which is free from square root. So squaring, we get v squared equal to, now we get pi squared r raised to power 4 upon 9 L squared minus r square. Okay, now we open this. Now here in over here we have to replace this L square by L in terms of s, so that we get everything in terms of r and s, which is a constant and r is the only variable. So we get v square equal to, first of all let's write it as pi squared r4 over 9 into L square minus pi square r 6 over 9, which is equal to pi square r4 over 9 into, in place of L we will write this. So we have s over pi r minus r whole square minus, and this gets carried down as it is r6 over 9. So it comes, or what we can do is we first simplify this part. We first simplify this part, that is the value of h square, and then we open this up. So instead of this whole thing, we can directly write this as v square equal to pi square r raised to power 4 over 9, and in place of L square we write s square over pi square r square minus 2 into s over pi r into r plus r square. This is the value of L square, minus r square is as it is, this gets cancelled, and so what we get is, here v square equal to, now we open it up, pi square s square over 9 pi square r square, and this is r4. This is the first term. So pi square I have taken down, s square r4 upon 9 pi square r square minus pi square r4 over 9 into, now here this gets cancelled. Now what we get is 2s over pi. Okay, now this gets simplified 2, now this gets cancelled, we are left with 2, pi square gets cancelled, now here 1 pi gets cancelled, and that's it. So we are left with, here we are left with s square r square over 9, minus, here we are left with 2s pi into r raised to power 4 over 9. Now let's take whatever common we can take, that is, we have got v square is equal to, now we can take s over 9 common, we are left with s r square minus s over 9 we have taken common, we are left with 2 pi r raised to power 4. Now differentiating, now for maxima or minima, we need to find the derivative. So differentiate with respect to r. So we get d by dr of v square is equal to s over 9 is as it is, it becomes 2sr minus 8 pi r cube, which can be written as s over 9, r can be taken common, in fact 2 also can be taken common. So we are left with 2sr over 9, and here we have s left minus here 2 and r has gone. So 4 pi r square. Now for maxima or minima, we have to put d by dr of v squared equal to 0. So this gives us either r equal to 0, which is not possible, or s minus 4 pi r square equal to 0, which gives us r square equal to s over 4 pi, or r is equal to under root of s over 4 pi. Now corresponding to this we have to check the second order derivative. So to find d2 over dr2 of v square. Now we first write d by dr of v square. What is d by dr of v square? We have got 2s over 9. I am taking this r inside, and so we get sr minus, and here I have got 4 pi r cube, 4 pi r cube. So therefore d2 over dr2 of v square comes out to be 2s over 9. This becomes s minus, this is 12 pi r square, which is definitely less than 0 because this part is much bigger, and which implies maxima. It implies that corresponding to when r is equal to under root of s over 4 pi, we get volume is maximum. Now we have to find the value of alpha in terms of sine inverse, and so we find sine alpha first. So clearly from the figure we see that sine alpha is equal to r over l. So we write it as sine alpha is equal to r over l. But we know that L is equal to s over pi r minus r. So we can write it as sine alpha. More so, this is r is in square root. So the better way would be we find L square and then take the under root. So we write it as r over L square whole under root, and this gives us square root of s upon 4 pi upon square root of, now L square would be s square over pi square r square minus 2 s r upon pi r plus r square. This gets cancelled, and so this becomes sine alpha equal to square root of s over 4 pi whole upon. Now this becomes square root of, now in place of r square we can write r is square root of s upon 4 pi. So r square would be s upon 4 pi. So into s upon 4 pi minus 2s upon pi plus, in place of r square we again write s upon 4 pi. So this gives us square root of s upon 4 pi whole upon. Now this one s gets cancelled, one pi gets cancelled. So we take the LCM as 4 pi and we get, now here it is, the denominator is pi. So we have got 4s here, 4s, and to make it 4 pi we multiply it by 4 minus, this is 2 into 4 to make it 4 pi plus s, and so we get the answer as sine of alpha is equal to square root of s upon 4 pi whole upon, this is 4 pi, and now here this is 16 minus 8, that is 8s plus s, and this gives us under root of s upon 4 pi upon under root of 9s upon 4 pi. This gives us 1 upon 9 whole under root, which is 1 upon 3, and this gives us alpha equal to sine inverse 1 upon 3, hence proved. Thank you.